Have you ever wondered if humanity could survive if we turned off the sun for a single year? Without sunlight reaching Earth, our planet would slowly radiate its heat into space. Every day would be colder than the last. Global temperatures would first drop to -18 degrees Celsius and just keep falling. The polar regions would freeze deeper than ever before. Soon, sheets of ice would creep from the oceans toward the equator. Plunged into endless darkness, plant life would die off within weeks. Without sunlight, photosynthesis stops, leaving them unable to produce nutrients. As the food chain collapses, animals would gradually follow suit. Months later, global temperatures would plummet. Almost all of the world's oceans would begin to freeze over, though a complete freeze would take much longer. The atmosphere would become dangerously frigid, whipping up violent winds and massive global blizzards. Even if humans managed to find ways to stay warm and grow food underground, Earth's surface would become virtually uninhabitable. Fast forward 1 year, we turn the sun back on, but Earth remains locked in ice. Massive ice sheets would reflect most of the incoming sunlight back into space, causing the planet to warm up incredibly slowly. It would take a very long time for Earth to completely thaw out. What would it take to terraform the moon and make it habitable? First, the moon rotates way too slowly, spinning just once a month. That won't work. We need to speed it up to a 24-hour cycle, just like Earth. This gives us a normal day-night cycle, making daily life much more comfortable. Next, the moon needs a planetary shield, a magnetic field. Earth has one to block deadly solar radiation. Without a magnetic shield, any atmosphere we pump onto the moon would be stripped away by solar winds in no time. Once the magnetic field is up, we can introduce an atmosphere similar to Earth's. As atmospheric pressure rises, the moon's surface temperature would begin to equalize. With the right temperature and pressure, liquid water can finally exist. Then, we flood the lunar maria, lunar plains, covering about 16% of the moon's surface with water. Thanks to the stabilized climate, these new oceans would stay liquid. And just like that, a celestial body that used to spin once a month now rotates every 24 hours. A new magnetic field protects its atmosphere, and the dry lunar plains are now actual rolling oceans. Our dusty, gray moon has finally become a habitable home for humanity. Next up, let's terraform Mars while we're at it. Mars's rotation speed is already pretty close to Earth's. A day lasts about 24.5 hours. That's a fantastic head start. First, we give Mars a magnetic field as strong as Earth's. This will shield the red planet from lethal solar radiation and keep its atmosphere from being blown away into space. Next, we thicken the Martian atmosphere, building it up across 5 layers until it matches Earth's atmospheric density. As the atmosphere thickens, it starts trapping heat, gradually warming the planet. A few years later, as the atmosphere stabilizes, dramatic changes begin to unfold. Rising temperatures cause the polar ice caps to melt, releasing frozen carbon dioxide and water vapor, which thickens the atmosphere even further. Now, clouds begin to form in the Martian sky. For the first time in billions of years, liquid water flows across the surface of Mars. Atmospheric pressure continues to rise until it equals Earth's. Armed with a thick atmosphere, a protective magnetic shield, and liquid water, Mars could very well become humanity's second home in the solar system. And just like that, a frozen desert planet is transformed into a world teeming with life.